Recently, I came across this website on Awwwards, which was featured as Site of the Day on February 27 this year, and it has some really interesting animations throughout the site. But the one that really caught my attention was its loader animation. It starts with a tiny block in the center, which quickly transforms into a collection of small image tiles. The images then spread out, arrange themselves into a different formation, and eventually rotate and expand into the main gallery. What I really like about it is that the loader doesn't just disappear when the page loads, it actually becomes part of the website itself. Following that idea, I put together my own version using React and GSAP. In my version, the images start as tiny squares, transition into a vertical gallery, and then continue into an infinite scrolling effect. In this video, I'll walk you through the whole thing and show you how to build a loader like this yourself, from preloading the images to the different animation phases and finally turning it into an infinite scrolling gallery. So, without wasting any time, if you enjoy this kind of creative coding content, make sure to subscribe to the channel and like the video. Now, let's get into the code. Inside app.jsx, there's not much going on. I'm simply importing the loader animation component and rendering it here. First, I define a few constants for the gallery. These control the landscape and portrait card sizes, the gap between cards, the wheel scroll speed, the scrolling damping, and the amount of parallax applied to the images. Then I create a small helper function that decides which dimensions to use for each image. Even indexes get the landscape size, while odd indexes use the portrait size, giving the gallery that alternating layout. Next, I create refs for the main container, the image track, the scrolling container, and the individual squares and images. These refs will let me control and animate each part of the loader and gallery with GSAP. Then I add two pieces of state to track whether all the images have loaded and the current loading progress. I also duplicate the image array, which gives us two copies of the images that we can use later to create the continuous scrolling effect. Next, I create the main section that fills the entire viewport. It acts as the container for the loader and gallery, while also hiding anything that moves outside of the screen. Then I add the small placeholder at the center of the screen. This is the tiny block we see at the beginning of the loader, and its background gradually becomes darker based on the image loading progress. Next, I add the UI elements that will appear after the loader finishes. They're initially hidden with 0 opacity, and will reveal them later once the main loader animation is complete. Now I create the main container for the image loader and the track that holds all of the image cards. The scrolling container starts hidden and slightly scaled down, and will animate it into view during the first phase of the loader. Finally, I loop through display images and create a small container for each image. At this point, the cards are intentionally tiny and hidden, because we'll use GSAP to reveal them, shrink them into the small squares, and later expand them into their final sizes. Before moving into the animation, I import the required React hooks, GSAP, and the use GSAP hook, and then registering it. I'm also importing the image array from my assets file as raw images. This contains all the images we'll preload and use throughout the loader and gallery animation. Now I'm starting with the preloader using useEffect. First, I make sure there are images available, and then I'll keep track of how many images have finished loading. Next, I loop through each image and create a new image object. This lets me load the images in the background before starting the actual loader animation. Here, I create the onFinish function that runs whenever an image finishes loading. I increment the loaded count, update the loading progress, and once all the images are loaded, I set isLoaded to true so we can start the animation. Finally, I handle both successful and failed image loads. Once an image is loaded, I wait for it to decode before calling onFinish, which helps make sure the image is ready to display smoothly. If an image fails to load, I still call onFinish so the preloader doesn't get stuck waiting for a broken image. Then I set the image source to start the loading process. Now I move into use GSAP, but the animation only runs once isLoaded becomes true. This makes sure the loader sequence doesn't start before all the images are ready. Next, I collect all the image cards and their corresponding images from the refs, filtering out any empty references. Then I create the main GSAP timeline, which will control all 3 phases of the loader animation and keep their timing synchronized. Now we start with phase 1 of the loader. First, I fade out and slightly shrink the center placeholder. At the same time, the image container scales up to its normal size and becomes visible, followed by the small image cards fading in. This gives us the transition from the initial loading block into the first stage of the image animation. Now we move into phase 2, where the small image cards start taking their final shape. First, I reduce the gap between the cards so they move closer together. At the same time, each card shrinks down to an 11 by 11 square. The animation is staggered from the center, so the cards don't all change at exactly the same time. Finally, I fade in the actual images with the same center-out stagger, making the tiny squares feel like they are gradually coming to life. Now for phase 3, this is where the loader transforms into the actual gallery. First, I increase the gap between the cards again. Then I rotate the entire track by 90 degrees, while rotating each individual card in the opposite direction so the images stay upright. At the same time, the cards grow from those tiny squares back to their original landscape and portrait dimensions, creating the main transition into the gallery. I also add a small gap expansion and contraction during the rotation. This gives the cards a little extra movement as they spread out, and then settle back into their final spacing. Finally, I add the rotate end label so we have a precise point in the timeline to trigger the next part of the animation. Once the rotation is almost finished, I fade in the UI content so the page elements appear as the gallery settles into place. Then, at the exact end of the loader animation, I call setup infinite vertical scroll, which takes over and turns these images into the continuously scrolling gallery. Now I create the setup infinite vertical scroll function. I start by getting the number of unique images in the cycle and setting a cursor that we'll use to calculate the position of each card in the vertical layout. Next, I calculate the center position of each image within one complete cycle. For each card, I use its height and the card gap to keep track of where it should sit vertically. This gives me the center point of every image in the original set. Then I calculate the total height of one complete cycle and multiply it by the number of image sets we're displaying. This gives us total span, the full vertical range that the duplicated images will travel through, which we'll use later to create the seamless infinite scroll. Next, I calculate the initial Y position for every image, taking into account which cycle it belongs to. Then I find the midpoint of the entire group and subtract it from each position. This recenters the whole set around the middle of the screen so the gallery starts in the correct position. Now I apply those calculated positions to each card using GSAP.set. I position every card absolutely at the center of the container, then use the calculated Y value to place each image vertically while keeping its rotation reset. Next, I reset the rotation of the track back to 0 and set up the scroll container using the landscape dimensions. I also remove any gap between the elements so everything starts from a clean, controlled position. Then, I create two variables to keep track of the current and target Y positions. Then, I use QuickSetter to create optimized functions for updating the Y position of both the image targets and their corresponding image elements. This lets me update their positions efficiently during the animation. After that, I create the render function, which runs continuously during the animation. Here, I calculate the time between frames and use damping to smoothly interpolate the current Y position towards the target Y position. This prevents the movement from feeling too sudden and gives the scrolling a smoother feel. Next, I loop through all the targets and calculate their Y position based on the current scroll value. The modulo calculation keeps the images within the total span, allowing them to wrap around and create the infinite scrolling effect. Finally, I apply the calculated position to each target, while also moving the images in the opposite direction using the parallax factor. This creates the parallax effect as the gallery scrolls. Next, I add the render function to the GSAP ticker so it continuously updates the animation. Then, I create a wheel event handler that updates the target Y position based on how much the user scrolls. Finally, I add this event listener to the window and set passive to false so I can prevent the browser's default scrolling behavior. Finally, I return a cleanup function that removes the wheel event listener and the render function from the GSAP ticker. This makes sure that when the component is unmounted or the effect runs again, we don't leave behind any unnecessary event listeners or animation loops. And here's the final result. We built an image gallery that starts with a preloader and smoothly transitions into a horizontal layout before rotating into a vertical scrolling gallery. We also added infinite scrolling, so the images continuously loop as you scroll, along with a subtle parallax effect on the images to make the movement feel more dynamic. If you enjoyed this tutorial or learned something new, don't forget to leave a like and subscribe to the channel. Thanks for watching, and I'll see you in the next one.